Hi guys, let's look at the next question. The next question that we're doing is question number 18. Before we start it, let's just quickly revise the tests of similarity. We first had AA, which means two angles are equal on the two triangles. Next we had was SSS, which means the ratio of these three sides is in the same proportion, which means the ratio of sides of triangle 1 is equal to the ratio of sides of triangle 2. And then the last one was SAS, which means one angle is the included angle is equal and the sides which make that angle are in the same proportion. Perfect. And now let's look at this question. Question says in triangle PQR, angle Q is equal to 90 degrees. Since no rough diagram given or no diagram given, let me just create the diagram. Angle Q is 90 degrees. This is Q, this is P, and this is R. Perfect. QM is perpendicular to PR. So there is a QM which is perpendicular to PR. Done. This is also given. Next, prove PQ square is equal to PM into PR. So like I said, in my rough work or in my mind or in the notebook, I would write what I need to prove in the form of a fraction. So PQ, one PQ goes down. On here, let's take PM. So PM, what remains here is PR, and what remains here is PQ. So if I can prove this equal, which is if I can prove these two triangles similar, then I should be able to get this very easily. Let's look at the two triangles. So I have PQR, which is that big triangle, and I have PMQ, which is the small triangle here. So that's at least this part done. Now let's try and look at these two triangles and prove them similar. So I will draw them separately to understand. This is PQR and this is PQM. Done. Let's see if I can get any equal angles. Angle Q and M are equal because these are 90, and angle P is a common angle between them. So this is QPM and QPR are the same angle. Perfect. Let's just write this down. In triangle PQR and triangle PQM. Number one, angle PQR is equal to angle PMQ is equal to 90 degree. This is given. And number two is angle QPR is equal to angle MPQ, common angle, which means triangle PQR is similar to triangle. Angle P was equal to angle P, so I will write P here. Q, which is 90, is equal to M, so I'll write M here, and that leaves Q here. So this is by AA test. Done. That gives me the corresponding sides of similar triangles are in proportion, which means PQ upon PM. I take the first two here, so I take the first two here. Then is PR upon PQ, which is 1 and 3, 1 and 3 here, and then the last is 2 and 3, which is QR upon MQ. This is CSST. Let's see what we have to prove. We have to prove PQ upon PM is equal to PR upon PQ, which is these two, which means PQ square is equal to PR into PM. Done. That's what they wanted us to prove. So this is answer to part 1, hence done. Part 1 done. Let's look at part 2. So again, for doing part 2, I'll first figure out which triangle to prove similar. So I have QR square is equal to PR into MR. Let me just write this in the fraction form. I'll leave one QR here and I'll take which one down? Let's say PR down, and I have MR here and QR here. So QRM, which means this small triangle here, QRM, and this is PRQ, which is the big triangle. Okay, so let's just put this here. This is PQR and this is M here, Q here, R here. Okay, okay, let's just write this. So this would be in triangle PQR and triangle QMR. This was 0.5, so we go to 0.6. Angle PQR is equal to angle RMQ is equal to 90 degree. This is given. So we've got one angle equal here. Anything else? Yes, I noticed that angle R, which is QRM here, and QRP here are the same angle, which means angle R and angle R here are equal. Let's just write this. Angle QRP is equal to angle MRQ. This is common angle. Next, therefore, triangle PQR is similar to triangle. I don't know what P was equal to, but we've got Q equal to M. So second place I write M, R was equal to R, that leaves only Q here. So PQR is similar to QMR, which means I can write the corresponding sides of similar triangles are in proportion. So this would be PQ upon QM is equal to PR upon QR is equal to QR upon MR. This is CSST. Done. Let's see, they wanted QR square, which means I am looking at these two. Let's write this. This will be QR square. This is point number 10. QR square I multiply will be equal to PR into MR. That's what they wanted us to prove. Done. This is answer to part 2. Hence proved. That brings me to the last part of the question, which says PQ square plus QR square. Now in part number 5, I did PQ square, and step number 10, I did QR square. Let's just add them. So from 5 and 10, I get PQ square plus QR square is equal to PR into PM plus PR into MR. I notice PR is common to both of them, which means if I take PR out, what I'm left with is PM plus MR. And what is PM plus MR? PM plus MR is PR. So this is PR multiplied with PR is equal to PR square. And the left hand side was PQ square plus QR square. So this is what my part 3 is, and I have already proven that as well. So that proves part 3 as well. Perfect. Again, a very interesting question. First, we took the big triangle and took one small triangle. This is the one where I said you should look at a common angle type of a triangle. Next, for proving part 2, I took the big triangle, and this time angle R was common in this small triangle here. So please again notice I haven't proven PQM and QMR similar. These are adjacent triangles. I haven't proven them. So highlighting the trick, first try and look at vertically opposite triangles. Rather than first trick, look at numerator to numerator, denominator to denominator. Then look at vertically opposite triangles, and then so this is point number 2, and point number 3, then look at triangles with a common angle. If you keep these small 3 tricks in your mind, you shouldn't go wrong with any question from this chapter. Good, let's look at the next question. The next question that we're doing is question number 20. PQRS is a parallelogram, which means opposite sides are equal and parallel. So RQ is parallel to SP and QP is parallel to RS, and they are equal. PQ is equal to 16. So PQ is 16, QR is 10. So this is 10, which means SP is also 10. RL is to SP, LP is 2 is to 3. So RL and LP. So let this be 2x. So this would be 3x. Let's just write that down. Let RL is equal to 2x. Therefore, LP is equal to 3x. Done. Next, what do we have to look at? This part done. We need to find length of PN and RM. PN, which is this big side here, PN. This is part of only one triangle, which is PNQ. Yes, it is not a part of any other triangle. Yes, or I can look at this small triangle and this small triangle. This way, if I can find NS, I can find PN then. First, let's look at the big triangle. Yes, so and the other one is RM. RM is this small triangle, RM. So then if I try and do this similar, then I will look at the vertically opposite triangles like I said. So I will look at RLM and PLQ, these two triangles. I have marked them in red. Like I've said, first thing you should try and look at are vertically opposite triangles. So let's just look at these two triangles and see if we can get something out of this. So in triangle RLM and the other one was PLQ. RLM and PLQ. What we get is point number 2 is angle RLM, which is this angle, and this angle, which is angle PLQ, are equal. These are vertically opposite angles. Next, since these are parallel lines, which means this angle here, angle R, and angle P here are equal because these are alternate angles. Similarly, angle M here and angle Q here will be equal because these are parallel lines, and then this is the transversal. So let's just write this down. Angle LRM is equal to angle LPQ. These are alternate angles. What does this give us? This gives us point number 4, which means triangle RLM is similar to triangle R was equal to P. So I'll write P here, L equal to L. That leaves only Q by AA test. Done, which means RL upon PL is equal to RM upon PQ is equal to LM upon LQ. Let's see if we have the number, if we have the data for this. RL, this is given as 2x, PL given as 3x, RM not given, PQ 16, RM is what we need to find out, PQ is 16, which means RM, why did I write PQ here? I should write 16 because PQ is given as 16. Okay, so PQ is given as 16. So I will write 16 here, which means RM will be equal to 16 into 2 upon 3 centimeter. 32 upon 3. Therefore, RM is equal to 10 2 by 3 centimeter. Let me just confirm if my answer is correct because this seems to be slightly odd. Yeah, but the answer is correct. Perfect. So this is 10 2 by 3 centimeter. Done. Let's look at the next part of the question. This time I need to find PN. Where is PN? So PN, like I said, is a part of this big triangle or is a part of this small triangle PLN. And again, if I look at, so let me just highlight it with a different color in case it is still visible after having done all these colors already. So this is one triangle PLN, and I can look at this vertically opposite triangle RLQ. So this should give me the value of PN, and these are vertically opposite triangles, so making my life simple as well. So in triangle PLN and triangle RLQ. So again, this, let me just draw them separately. There's too much overwriting that I've done on that one diagram. This is LNP. So angle L and angle L here are equal. These are vertically opposite. And again, angle Q here and angle N here are equal because these are, this line is parallel to this line. NQ is the transversal. So these are alternate angles. So angle Q and angle N are equal. Let's just write that down. So this is point number 7. Point number 8 would be angle NLP is equal to angle QLR, vertically opposite angles. Next, angle LNP is equal to angle LQR. These are alternate angles. Therefore, triangle PLN is similar to triangle L is equal to L, N equal to Q. So this gives me PLN is similar to RLQ. Perfect. Which this is by AA test. Done. Next point, let's look at the proportion. It will be PL upon RL is equal to PN upon RQ is equal to LN upon LQ. This is CSST. Let's see. Oh, I didn't write CSST here. I should write it here. CSST. Done. RPL is given equal to 3x. RL is given equal to 2x. PN, which is what we need to find. RQ is given equal to 10, which means PN will be equal to 10 into 3 upon 2, which is 15 centimeter. So I figured out the value of PN as well. Done. Interesting question. Before I finish, let me just quickly revise the tricks. Numerator with numerator. That's the first one to help you identify which triangles to prove similar. Second one, vertically opposite triangles. And third one is triangle with a common angle. And then the last one is do not look at adjacent. Right? If you have no option, you will have to, but adjacent should be our last option. Perfect. That finishes this video for me. Let's look at some homework question for you. Homework question for you would be question number 21. Okay. Question number 21 is your homework. Thank you so much. Bye bye. Take care. I'll see you with the next video.